Yeah, thank you so much, guys, for joining us today. It's been a great time here so far at Civo Navigate. The conference, the day one of the conference had some phenomenal talks. Like, I did not expect, sunny Austin to have such a vibrant tech community, but all the conversations I've had so far have been phenomenal. And that brings us here today. So the zero interest rate phenomenon is truly over. There's no denying it. And there has been an increased focus on cost optimization going hand in hand with performance optimization for quite some time. And so we're going to be talking about a few mistakes we made a while back in our configurations in long-term Prometheus metric storage that almost cost us upwards of $100,000. We're all going to make thousands of mistakes. Not every mistake is really going to count, but a few of the ones that we made today, they snowball together into a potential nightmare. And yeah, let's just dive into it.
Hello guys, good morning. I hope you're doing great. Thank you for being here. So my name is Pratik, this is Shubham. We are the founding team member of ZenDuty, a major incident management platform built for the SRE DevOps socket teams. So we have accumulated years of experience of making mistakes. That's how we learn. And learning from those, we are able to help 500 plus SRE DevOps, basically major incident management teams throughout the globe. So let's dive into, So this is the talk really going to about. First we will discuss why we need a solution like Thanos. Second, then we'll discuss why we zeroed in on Thanos only by discussing other solutions like Vectorize, Cortex compared to Thanos. Then our third thing is that what was our production setup that time and what was the expectation from it. And lastly, that's a bad joke, but the good, bad, and the ugly, not obviously not Clint Eastwood, it's a bad again saying, but what really went wrong, how we fixed it, and how much it could have costed us. Okay, so just to give you an idea, this is ZenDuty, the dashboard of ZenDuty, a major incident management platform. Okay, so what we exactly do, we connect with the entirety of our customer infra, support, and comm stack, like APM, server monitoring, area monitoring, log monitoring, comms like Slack, Teams, Zoom, and all. Okay, so we help them automate the incident process throughout, end to end. We're talking about from alerting to response orchestrations. Okay, so basically what exactly matters, why we are doing this, that we want to give a tool which helps them to solve the main problem, firefighting the incident, focusing on that. That is the main thing, correct? A few years ago, along our customer base, it started growing as rapidly that precisely when our observability stack also needed to set up a little bit. Thus, we went into market for a scalable metric solution.
Yeah.
Like that.
So why would you need Thanos? I mean, Prometheus has a simple and reliable operational model. I mean, it just works, right? It's capable of tracking millions of measurements in real time. It has powerful querying capabilities via Grafana as well. But however, past a certain scale, it has a few shortcomings that just become abundantly clear. It fails to answer a few questions that fast scaling teams naturally come across. Questions like, how can we store petabytes of data in a reliable, cost-efficient way? Can we do so without sacrificing response query times? Can we access all our metrics from one single API query? And can we merge replicated data collected via Prometheus HA setups? And turns out Thanos is the answer to most of these questions. So a few of the major reasons why we liked Thanos in particular. So first up, the global query view. So Prometheus encourages a functional sharding approach. So even a single Prometheus server provides enough scalability to liberate users from virtually all use cases virtually from the perils of horizontal sharding. And regardless, you would still often want to access all your data from one single API or UI, which is the global query view that I'm talking about. Like for example, you can render multiple queries in a single Grafana graph, but all of these queries can only be run against one single Prometheus server. With Thanos, on the other hand, you can query and aggregate data from multiple Prometheus servers because all of them are available from a single endpoint. Then it's the main point, which is the reliable historical data storage. So the Thanos sidecar watches Prometheus for new blocks of persisted data, and it pushes them into an object storage bucket. So you can store historical Prometheus data into any object storage bucket of your choice. We chose AWS S3. Then downsampling. So once you start querying historical data, there are some fundamental bigger complexities that make queries slower and slower as you query weeks, months, eventually years worth of data. And the solution to this problem is, well, good old downsampling. which is like, just to put everyone in the same page, like reducing the sampling rate of the signal or reducing the number of data points within a certain time period. So with downsample data, we can zoom out to a larger time range while maintaining, the same statistical context from older data and keeping our queries just as responsive. And lastly, high availability. So Prometheus has an HA model that independently scrapes data twice, which is as simple as it could be. However, the merged and deduplicated view that Thanos provides, I think it's a huge usability improvement in most cases. So we considered a few different solutions at that time, but some of them were either a little too young, not computer-driven, didn't support PromQL, or didn't have object storage, or sometimes, they just didn't gel well with the rest of our observability infrastructure. And Thanos seemed like the obvious option. That was the tool of choice for great engineering teams. A lot of people are flocking to it, and that's where we decided to be as well. So let's take a look at how we implemented Thanos, our beautiful Titanic before it hit the iceberg. So Thanos runs as the sidecar to the Prometheus instance and pushes blocks of data to object storage. We had implemented Prometheus in the Prometheus function starting in the HA mode, so which means we were scraping the same data twice from different AZs, mind you. And the setup requires the Thanos ruler over there to set the PromQL equations, which we'll use for alerting. And it needs to be connected to the alert manager in turn, which sends all our alerts to the final destination, which in our case was Zen, and Slack. The Thanos querier uses the storage gateway to get old data and is used by teams for any analysis or to create external or internal dashboards for the team members or PMs. And in order to get faster query results, our downsampler over there is used to downsample data and store it back to the object storage. Now let's see how we set up log aggregation via FluentBit, or the other bird app that we don't talk about as much. So FluentBit is a well-known log aggregate used for Kubernetes. It's a CNCF graduate product, I think. We deployed the daemon set and started exporting the logs to OpenSearch. And FluentBit uses a plugin to add extra labels to each line of the log stream. And for getting the extra labels like pod name, namespace, and other metadata pretty much, it calls the Kubernetes API for that information. And if the case API fails to send a response, it retries again and again, and after some jitter, it pushes the data to the destination with or without the logs. So what are expectations after this? Well, effortless querying, cheap long-term metric storage, leisurely downsampling data whenever and wherever we want, and pretty much just a much cleaner metrics and logging system. And this wasn't easy, mind you. It was open source, but it's still not easy. But we got it all configured. But like, should work straight out of the box without a hiccup, right? Not so much. In our naivety, we saw a bunch of anomalies and errors popping up that we couldn't make sense of initially, but eventually it all came together. So the first thing in this series of unfortunate events, we had an issue with our network topology. So a pretty basic thing. This is like second year of a computer science degree. But while we were building our log and metric handling infrastructure, we must to keep in mind of a few minor caveats that eventually cost us a little dearly. Next, just plain old high cardinality. I think there was a talk yesterday about cardinality as well. But we had too many metrics to monitor and scrape for our scale, and it combined with other issues to actually cause a bigger problem. And finally, our friendly neighborhood downsampler. There was a mismatch in our expectations and our implementation with the downsampler, causing an increase in network and storage costs. And well, this sounds intense, and it was. So let's just talk into what these things really were in detail now. So this is what a network topology was like. It's pretty basic, pretty generic, with multiple availability zones and multiple VPCs. The problem with this topology is that we are pushing a lot of log data through AWS S3, and all of this data was flowing through the NAT gateway every time, which means that we were getting charged egress costs, and this would pile up, and that would get to a certain stage eventually where it would start impacting us. The fix was pretty simple. We just added a VPC gateway endpoint, which identifies and separates our public and private traffic to S3. So whatever traffic needs to go towards S3 from our private servers will flow through the VPC endpoint, and everything else can still go to the NAT gateway as is. Again, pretty basic, but sometimes you need to burn your fingers a little before you can truly feel the ropes, I think. But yeah, again, guys, this was 3 years ago. So next, the high cardinality. So each attribute of an event over here is a column or dimension. And the term high cardinality here means that we pretty much just had too many possible values for a single attribute. So we get unchecked high cardinality for metrics data for some services due to the addition of dynamic tags to each metrics. Dynamic tags are pretty much tags that you can add to your metrics to observe and alert on metrics from different hardware profiles, software versions, availability zones, services, roles, etc. Pretty much any level you need. But tags do give you the flexibility to add metadata on the fly, but you should not be adding and observing metrics with dynamic tags that can be too dynamic or specific. So, for example, client IP addresses, session IDs, timestamps, and we made a few of these mistakes ourselves. And again, this clubbed with other mistakes to become a bigger problem. And finally, our big old downsampler, the Thanos compactor. Before we dive into all of this math, let's take a quick refresher on what downsampling really is. So downsampling is the process of reducing the resolution of your data, typically done by aggregating multiple data points into a single point on the basis of a single interval, which can be through averaging, summing, or taking the maximum or minimum points. And this process helps you retain larger, older time series data by replacing the data with a data stream that represents your larger data set and is much shorter, but has all the statistical representations you would need to derive context later. And the original metric samples may have been taken, for example, let's say every 10 seconds, but as the data ages, you can choose to reduce the sample's granularity to hourly, daily, maybe even weekly. So again, the Thanos compactor here is used to downsample the raw data to reduce the storage requirements and improve the query performance. And Thanos provides a pretty basic downsampling compactor where it provides you retention of very specific days and downsampling up to only two levels, like 5 minutes and 1 hour, I think, which is what we were using earlier. Another problem with the default Thanos compactor was that if we had to downsample any data, the main object storage needs to be available. So what that means is, let's say that in the case that data needs to be downsampled to 40 days, right, to a 5-minute resolution point, the main data needs to be stored for those 40 days. Now, once I'm doing this process again for 180 days, I still need my original data. So it's not using anything from my previously downsampled data. I'm essentially storing the same data thrice with different resolutions. And when you combine this downsampling problem with the VPC cost and the high cardinality, it's just a completely different story then. The fix was simple. We pretty much just wrote our own Thanos compactor. So our flavor of the compactor gives a lot more flexibility to developers. Teams could now downsample data, like choosing thresholds on their requirements. It could be 10 minutes, 30 minutes, 1 hour, 2 hour, 12 hours, whatever you need. They don't need to keep the original object storage anymore, which was the crux of the original problem. As soon as the first downsampling operation is done, they can pretty much go forward with any future downsampling operations with large time periods. And in our case, any raw data was not available after 3 days. So we added custom retention options, custom start dates, and a few other usability improvements to our downsampler that makes the experience a lot better for anyone who's maintaining this. We're going to be open sourcing it soon. It works flawlessly with Prometheus so far. We're going to be testing it with Victoria Metrics, Cortex, and I hope, and maybe Mimir as well. And this was a surprise one. But we used FluentBit as the middleman to aggregate logs from different sources and send it to respective targets, which I talked about earlier. We were pretty happy with the choice, but we started observing that the data aggregated by a middleman itself is generating a lot of error logs, but there was no clear pattern of why it was happening. Over time, we observed that this anomaly is affecting our cluster API and choking the bandwidth as well. Turns out this was happening due to a misconfiguration in a subpath mount of the Kubernetes volume for our pod, due to which the request to add extra labels on a particular line of the log was recursively being called, and all of this log data was being transferred to CloudWatch, which was pretty much adding all of the cost to our problem. And we did fix all of that, and with proper monitoring, we were...
So, and great, with proper monitoring, we're able to not only detect these anomalies, but fix them on time. So, we would like to give a pat on ourselves, a back of ourselves. But now that hadn't been some while. So we did some kind of cost analysis of how much this little mishap could have costed us. And it's surprisingly a lot. Yeah. So I would need my notes for it because it's a lot of numbers. and that too in huge numbers. Okay, so let's see how much this sort of could cost us. The following cost analysis is for one single cluster in region per month. Okay. Yep.
Yeah.
Sure. This one, no?
Yeah.
Okay. So data process per NAT gateway around 50 dB. Gateway usage hourly cost comes down to 730 hours in a month. Okay. Multiplied by 0.45 USD, it comes around $32.85. But the NAT gateway data processing cost was around 51. It's basically 51.2 kgb per month times 0.045 time USD for around $2.3K. Adding them together, we get around 2.3K USD per NAT gateway. As we had 6 NAT gateways, total NAT gateway uses and data processing cost comes to around 14K per cluster.
Yeah. So for logging, our daily data consumption was around 108 GBs, multiplied by 30 for the monthly cost into 0.5, which is the ingestion cost, comes to around 1620, not much. And then we'll add the transit cost as well. And total is a pretty neat 1717. And again, the total comes to 15.7K. But this is per cluster per month, remember. And we were running around 6 to 8 clusters at that time. This was 3 years ago. The scale has spiraled a little bit further, but I'm pretty sure a few of you in the crowd have you're handling a lot bigger scale in this, and then these numbers would have spiraled to bigger heights and raised some eyebrows and blood pressures for sure. So like a few things that we would like to leave you all with. So the smallest mistakes, hardest to fix, and in turn more expensive. There's this quote that I've always loved from Anthony Hopkins. It's evolution forged the entirety of mankind and sentient life on this planet using one single tool, which is a mistake. So don't count it out. Second, don't rush into things because it's just easy to drop in. I mean, there's been a lot of chatter in the past couple of years about shifting to open source solutions, reconsidering what you're using right now. But do your due diligence properly before, adopting something that you might not need right now. Nothing is a silver bullet, even if people are telling you that you can implement something in like 30 minutes and be done with it. But nothing is ever going to solve all of your problems. And lastly, if you are one of those rapidly growing build fast, break fast teams, it's worth spending on extensive monitoring and alerting, regardless of your scale or size. And yes, of course, a quick thanks to everyone at the Kubernetes, Thanos, and FluentBit ecosystem. I really love this XQ series. I think it captures our ecosystem pretty well. And yeah, that's it for now, guys. Pretty short. And we'd love to take a few questions, maybe off the stage. If you're looking for like facelift in your incident response ecosystem, to reach out to us. We're going to be hanging out in the hall. And yeah, keep rocking observability. Thank you, guys.
You guys.
Yeah.